And now let's switch to English for the next segment. Satya Nadella is about to join us. He will tackle now how machine learning, data science, and of course, cloud can empower every person and every single organization to do more. Décidément, cette présentation en anglais, ça vous émeut. À tout de suite.
5 years from now, we're going to have computers that we wear on our wrists, computers that we wear on our eyes. There's going to be small screens, large screens. There's going to be sensors in every room, living rooms, conference rooms, which is all going to be capable of running general purpose compute. But the real idea is for us as we move about to have our applications, our data, our experience move with us. And that's where the cloud plays a huge role, because that mobility comes because of the cloud. In that context of mobile first, cloud first, Microsoft has 3 bold ambitions. The first one is about reinvention of productivity. And you could say, what? Well, that's something that's solved. But to us, in all this abundance, what is scarce still is human attention and time. And the idea that we can help allocate your attention, your time in more and more efficient ways is at the core of what drives individuals, organizations, and entire economies. A second ambition we have is to create a very rich platform in the cloud for you to be able to harness the power of data. The idea that you can take data from an exhaust and convert it into fuel is what's going to drive modern business, modern economies. And lastly, our ambition is to invent new, more personal computing and new personal computers. What we are trying to do with HoloLens on one end or the Surface, all of that speaks to this fundamental notion that we can change computing. But at the core of all this innovation agenda is data. If you look at what's happening with data, we see it today, especially with the advent of Internet of Things. The fact that we have billions of things now. There are more devices than human beings on the planet, all generating data because they're all running applications that generate data, that are all rendezvousing back with the cloud. We have something like 10 zettabytes of data today. That is 10 million petabytes. And someone described that as essentially stacking up a bunch of DVDs up to the moon 1,250 times. And now, by 2020, it's forecasted that we are going to have 50 zettabytes of data. But the question really is, what are we going to do with all this data? How are we going to convert this exhaust of data to become the fuel? And that's where I think the ingenuity of all of you who are studying to take that data and convert it into fuel, to convert it into real intelligence and real insights that move our companies forward, economies forward, and society forward is what's perhaps at stake. So I wanted to walk through a set of examples that I think bring home what this opportunity really looks like. In fact, the first one I want to talk about is what we're doing in terms of inventing new personal computing. The fact that we are changing personal computing to have new forms of input, where it could be inking. Ink recognition only becomes great because of our ability to recognize through the power of data how people write digitally. Speech recognition, image recognition, face recognition, these are all the things that are now standard part of what is our Windows experience across all of the devices we are creating. From Surface to Surface Hub, the HoloLens is perhaps the most mind-bending of those, because for the first time in our history, we now are not only taking what's available in the analog world and creating a digital metaphor, but we are able to superimpose a digital artifact, in this case a hologram, in the physical space, essentially creating a new medium. Again, the ability to essentially see a scene, reconstruct it, and then to be able to position digital objects in it. That's all the power of new algorithms, new data. Another area is Cortana, or intelligent agents. Just like the PC operating system in the past, the web next, I think of intelligent agents as the third runtime. The notion that we're going to be invoking multiple different applications for all the tasks, I think that's an app model that 5 years from now will be gone. We're going to talk to an agent that is capable of, in fact, helping us with our tasks that span all the applications in our lives. That is again a future where you're able to understand semantically the instructions you give, either through speech or through text, and to be able to invoke the right set of applications or orchestrate the right set of applications. Today when I'm using Cortana, not only am I using it to get things done, but I'm also using it to remind me of places I go to, people I need to talk to. So that's another form of how digital technology and data and algorithms are going to fundamentally change our world. And another example of this is Skype Translate. I believe a video was played a little earlier as part of this conference. It's just amazing to see how three distinct technologies that are in fact developed independently, speech recognition, machine translation, and speech synthesis. These were three different technologies that have developed over the last 40 years. But now you're able to build a deep neural network that brings these three technologies together. But most importantly, the data from Skype, which makes it possible for us, for the first time in our history, to be able to solve for the language boundary and the barrier that exists in real time, to be able to translate between French and Chinese. Another thing that I'm very excited about that's happening in all of our lives is health and wellness. We see it. When I wear the Microsoft band and I go for my run in the morning and to everything else I do through the day, the fact that we have all these sensors. In fact, I think of this more as a sensor platform for everything from UV exposure to the GPS, to the continuous heart rate, to all the things that you measure on a continuous basis. But now, not that the fact that you have data, but think about it. Over the years to come, people will invent new pattern recognition algorithms that will go back and look at all of our data and predict, and more importantly, help us as we try to be healthy in our lives. In fact, inspired by what's happening in the consumer space of quantified self and wellness, we're applying the same approach to what's going to be the case for driving organizational productivity. Because earlier I talked about how the most scarce commodity we have is time. What if we had a system that had the ability to reason over all of our interactions at work? It knew me, it knew my organizational structure, it knew whom I work with, whom I need to work with, it had my calendar information. It really reasoned about all of those artifacts in a graph-like structure and gave me feedback. So Delve Analytics is a tool that we've built, which is very much like your health portal, telling you that you're spending maybe far too much time in meetings internally versus talking to students at Sorbonne. And those are the kinds of things that will allow you to allocate your time more productively, make new connections to make things happen. So that's another way of data and intelligence is getting used. Now, of course, it's not just about Microsoft products. If anything, you heard, I think, from Louis Vuitton in terms of students here who worked with them on a hackathon to transform the foundation of that business, which is very, very exciting. And I'm seeing this now in every industry, in every country. ThyssenKrupp is an interesting case study because they're an elevator company, but they don't think of themselves going forward as an elevator company. They think of themselves as building a digital service that knows how to do preventive maintenance of elevators. Because if you have an elevator in a hospital, perhaps your need for doing preventive maintenance is a lot more than an office building. So the gross margin that existed on the elevator is moving from the thing to the service. And again, that fundamental transformation is because of the power of the cloud and the ability to do machine learning and statistical machine learning to do simple things like preventive maintenance. Another example is from here at Grand Lyon, where we worked with Exis to really come up with a pilot, which is pretty ingenious. What they did was they built a mesh network by essentially networking the public transport system so that they can collect data that helps the city get better at their environment management. They, for example, now can really get the latest in terms of air pollution. So it's not just about, then of course they have a mobile set of applications, so they crunch it in the cloud, they can then go notify all of their mobile clients. But it's not just about the notifications, but it's the ability for them to predict. Because the real chain across all of these examples is for data to be used so that you know what happened, why it happened, to predict what is going to happen, and more importantly, do something about it, act. That chain is what now can be used not only to do things like business transformation, but to change the outcomes in our environment by smartly measuring what's happening around us. Another example is what we see happening with a connected car. Now you would say, what is wrong with this guy and why is he talking about connected cars? But I tell you, this example from perhaps the oldest of human endeavors, which is animal husbandry, speaks to the power of transformation. Because I believe, I don't know much about this industry, but I've learned that productivity matters. And in order to really be productive, you need to be able to take advantage of that brief period of time that a cow goes into estrus, I believe. And this is, by the way, a technical term for a cow going into heat. And so how do you do that? They've turned out, Fujitsu went and figured out that by actually measuring the total number of steps a cow takes, basically a predictive algorithm that sort of looks at the movement of cows and predicts that period of time that you truly can utilize to increase the productivity. And I mean, I just look at that example and say, of course, they did the natural thing. They put pedometers on cows, they started measuring it, so they now have a predictive algorithm to be able to go look at what has to happen. They've gone and even sort of figured out that a particular form of intervention can even control the gender of what type of cow is born next. This must be the first example of where artificial intelligence is being used for artificial insemination, and that's sort of fascinating by itself. But it is the fact that data is being utilized in every field in every walk of life that I think is perhaps the most exciting part of our industry. We're building out a very rich data platform. In fact, when I joined Microsoft in '92, one of the most exciting parts of the journey was to democratize what became client-server development. What I see today, as I stand here, is the opportunity to democratize data science and machine learning, because that's what's going to really define what happens in the industries and in the economies going forward. And that's the set of tools that you can utilize to have your impact. But it's not just the magical algorithm. One of the things that we have to really think about is, where are the humans in this? Are the humans in the loop, or they're not? I fundamentally am a believer that human ingenuity is not substitutable. It is about being able to use artificial intelligence to amplify our ability to have an impact. Digital technology as a factor of production, not as a substitute for labor. And one of the best ways to see this is in all the big data, in all of the magic of machine learning, you still have humans who can recognize those small patterns and act. That makes all the difference. And I wanted to show you some of that work by having Amer Netz, one of my colleagues, join me on stage to show you how tools can be used to amplify human ingenuity. Amer, come on in.
Thank you, Satya. I just love the story about the cows in lab that generate data. You know, we have everything generating data today, and you have so much data, you really have to have tools to be able to visualize it, to explore it, to find some insights. So I'm going to show you some really, really incredible tools today. And I want to show you here something that we call Power BI. Power BI is a free software from Microsoft. You can download it, go to powerbi.com, and we'll see how we explore data. And the data I'm going to show you here is real data from Microsoft. I flew into Paris this morning, and I booked my ticket through the travel department of Microsoft. We have 100,000 employees that use the travel department of Microsoft, and the travel department gave me the data. So we can see some interesting things about flights of Microsoft employees. For example, we can see how much money Microsoft is spending on travel, and you can see that it's quite a lot. It's hundreds of millions of dollars we spend on travel. You know, 100,000 employees, yes. And you want to see where we travel? We just go and break it down by the city. We can change the visualizations, and we can see here that Seattle is the most frequent destination for Microsoft employees because we are headquartered just near Seattle, so that's the airport that serves us. Now that's one way to look at the data, just as a bar chart, but we have so many different kinds of visualizations. So how about if we look at location, how about we use a globe to show that? And just like that, we're going to see all the information around the globe. And this shows us, you know, where we spend most of our money. But are we efficient? The best way to check to see if we are efficient is to see how much we spend for every mile that we travel. So we have here another measure that is called cost per mile, and when I throw it in here, what you can see is a heat map that tells me that on the east coast of the United States, it's much more expensive to travel per mile. It's also pretty expensive in Europe. But what is the most expensive place to fly for Microsoft employees? Well, I'm going to show you. We'll take the cost per mile, and we're going to break it again by the city. And we're going to change visualization. And what you can see here is that it is, well, I'm going to show you a bit larger here. We have two top destinations here, and kind of pretty relevant to you. So let's see it. We have this, Limoges is the second most expensive city, yes. But the most expensive one is Monte Carlo. I want to show you something here, right? Little Monte Carlo here. See the map is zooming in on Monte Carlo. Let's see why it's so expensive. What happened that Microsoft employees are finding it so expensive? So let's see the trips that Microsoft employees took to Monte Carlo. I'm going to drop in the itinerary, and now we can see where they flew. I can see drop in here also how many miles they flew and how much they paid and what's the cost per mile. And what you can see here is something pretty interesting. I want to see here. This is the flights to Monte Carlo. And you can see the most expensive ones. The itinerary was from Nice to Monte Carlo, and Nice to Monte Carlo to Nice. Now, I don't know how much you know about the geography of France, but Nice to Monte Carlo is 14 miles, right? You don't have to fly. You can ride one of those cows of Satya, right? So what happened? Well, some Microsoft employees did the following. You want to see the airline here. See what happened? Some Microsoft employees decided to take a helicopter ride from Nice to Monte Carlo. And I showed it to Satya. Do you know what he asked me first? What are their names? He wants to know their names. So, real data, absolutely real data. Now, the beautiful thing here is we can just go and explore the data so easily, and then we can go and create some really beautiful reports. Reports that may look like this, or reports that may, and that's fully interactive, by the way. I can go and click on Japan, and it slices and dices. Very, very easy, just drag and drop. Reports that look like this, and you think, oh, it's for the phone. You're right, it's for the phone, but it's not just for the phone. Look at this. If I publish the report to the cloud, now something really, really interesting is happening. I can go and start asking questions. I can go, for example, and ask travel data for Amir Netz. It's my travel data. And notice that the system doesn't give me just the web results. It tells me, hey, I know something about your data. And it's going to connect, and it's going to load this report now for me directly in Cortana. Your data in Cortana, and not just what is the Italian restaurant that is close by. It's your data directly in Cortana. And it is interactive. You can go and slice and dice. And I want to just look at my business travel, just like that. And if you're really romantic, you can ask other questions. For example, let's ask a question about, how about show me which cows are in heat? If you're really romantic. And what happened is, you can get here, and this is the same data that what Fujitsu was using for Satya's story, right? You can get the report here. Cortana knows about the data that you have access to. Cortana can give you the results. It's your data. Now, the cows in heat is a great story of Internet of Things, right? And the Internet of Things starts with having lots and lots of sensors that are emitting data, and we analyze the data. And I want to show you how we can build such an application. So first, we need some sensors. So we have some sensors. See, this is a sound sensor. And we bought it on Amazon.com. It cost us $61 after 10% discount. And we have installed in the room here those microphones. And what we're going to do is we're going to build an application of Internet of Things with this. Okay, so let me show you how it's going to work. First, these microphones send the data to the cloud. I'll just go here. And you can see they send it to something it's called Azure Event Hub, which is our cloud service that collects all these IoT events. And then we can go and process the data in Azure Stream Analytics, and we can have this query here that is running. And this query here, what it does is taking the data from all the sensors and grouping them and creating a rolling average of 1 second. And at the end, we can send the data back to the BI system, to the dashboard. So I can go in here, send it to Power BI. And when I do that, I get to have a real-time dashboard. And what you see here, this is the input, this is the output, this is the monitoring of the microphones that we have right now in the room. So we have two groups of microphones. You can see here we have the P microphones and the R microphones. And we can go and ask questions of those microphones. For example, I can go and, the way we ask questions, if you want to create one of those charts, you just ask it with natural language. So I'm going to ask here, volume by section for the last 10 seconds. And immediately I get it. Just ask the question in English and you just get the answer. And I can change the visualization. Maybe I want to have it as a column chart. Maybe I want to have it as a pie chart. But I can also have my own created visualizations just for me. And I can create those myself. So I created one here for this event. And this is a heat map of this room. So we can go and start monitoring. Now what I'm going to do is I'm going to pin it. And when I pin it, I'm going to go and flip back to the dashboard, and let's see what's going on. See, now we have a live image of the heat on this room, and we're going to do some experiment here. See, we have here the P microphones, and we have here the R microphones. I heard that students and parents like to have their voice heard, so we're going to test it. See, you guys here, you have the P microphones, and I want to see how loud you can be. You guys here have the R microphones, and I want to see how loud you can be. The way we're going to do it is when I give you the sound, you guys are going to scream, "Pa!" When we give you the signals, you're going to shout, "Re!" And we're going to do it again and again and again. Now, to test it, we have another custom visual. Just show us the custom visual here. This one here. See, it is a balloon. And we're going to see who explodes their balloon first. Are you ready to go? Just start it again. 3, 2, 1. That's data for you. That's how you have fun. Well, let's see what you do with it. Thank you.
Hopefully that for all time answers the question that human beings in a world of data are still going to be there, because the ingenuity of humans to recognize what is happening around us with the help of algorithms, with the help of visualizations, with the help of data is what's going to change the world. You all are at school at an amazing time. It's a time of a new renaissance where people across design, engineering, computer science, statistics are coming together to change every industry and every walk of economic and social activity. And this quote from Anatole France, in French you can read, but it essentially captures, I think, the essence of both the opportunity as well as the responsibility that we all collectively have. To make great things happen, you not only need to act, but to dream. You not only need to plan, but you need to believe, I think, is what we all do each day, which you all do each day. And I'm inspired when I see all of the work that I see coming out of your ingenuity. Thank you so very much. Have a fantastic day. Thank you.